Hello everyone, this is Pankaj and I welcome you all to new day, new question series. So once again we have one more question on the screen. Let's see what does this question is saying. So according to the question we have two identical conducting sphere P and S with a charge Q on each and they are repelling each other with the force of 16 Newton. So let's draw the diagram based on the question. We have here basically two sphere. Name of one sphere is basically we have P and name of another sphere is basically we have Q. So P not Q, it is basically S. Now charge on each sphere is basically Q, so charge on this one is also Q and this one is also Q. Distance, let's assume distance between them as basically D. So I'm assuming the distance between this two sphere as a D, and the force of repulsion between them, which I'm calling as basically F, which is equals to K Q Q by D square, which will be equals to K Q square by D square, and its value is given as 16 Newton. Now, what are they saying? Basically, a third with identical. Okay, so we know that whenever we touch two identical sphere, charge get equally distribute. So a third identical uncharged conducting sphere whose name is R successively, that is one after the another, brought in a contact with the two sphere. So what we are doing, we are bringing that third sphere whose name is basically R, which is uncharged. First I am like basically touching this sphere R with the P, and after that the same sphere I'm touching with the S. Let's see what will happen. So once again I'm redrawing this diagram. So same diagram I'm going to use here, but the charges, let's see. So what are we doing? We are basically taking the third charge. Okay, third, not chart, third sphere whose name is basically R and it is uncharged. So first what I am doing, I am basically making the contact of the sphere R with the sphere P. So what will happen? We know that whenever two spheres are brought in contact, if they are identical, they will equally distribute their charge. So right now the charge on the P is basically we have Q, charge on the R is basically 0, so Q plus 0 they will equally divide. It means the final charge will be Q by 2 and the Q by 2. So final charge on P will be Q by 2 and half of the charge of P will be taken by the R. Now next step, what are we doing? We are taking this R sphere and we are touching it with the S. Now basically R is bringing Q by 2 charge and S have Q charge. Total will be basically 3 Q by 2 and they will like distribute it half, so it will be 3 Q by 2 to the 4. It means each will have the charge of 3 Q by 4. So final charge on S is 3Q by 4 and this R will also have 3Q by 4, but we don't need that one. So now final force of attraction, which the force of repulsion will be F is equals to K Q1 into Q2 by D square. I'm calling it as F dash. So K Q square by D square and it will be 3 by 8. Now from equation number F, like from here we know that value of KQ square by D square is 16 Newton. So I'm going to replace that value with the 16. So F dash will be equals to 16 into 3 by 8, which will be 8 2s are, so 2 3s are 6 Newton. So final answer will be 6 Newton. Let's see any option we have regarding the 6 Newton. So as we can see, Option number B is our final answer. Okay, thank you.